Good afternoon, discussants. Good afternoon, chairman of the proceedings. Good afternoon, everybody. All protocol observed. My name is Disho from the Radiation Protection Inspectorate here in Botswana, from the Unit of Standards and Instrumentation. This afternoon, I shall be discussing with you I was supposed to be discussing dosimetry, environmental radioactivity, but I shall dwell on the issue of the standards as they are administered by the Radiation Protection Inspectorate. Thank you. We shall find further as we move along in our discussion. Okay, moving along, the first slide actually is talking about the standards, radiation protection and safety standards as are applied to attain radiation safety and protection. You will realize that in Botswana, the custodian and principal administrator of radiation protection standards is the Radiation Protection Inspectorate. And the role of the inspectorate, this role was actually conferred by an act of parliament, Radiation Protection Act, Cap 2304 of 2006. Botswana has adopted a mechanism of administering radiation protection standards to guide performance of exposure from the IAEA by localizing an international regulatory framework into a national statute. In this manner, it was a way of effecting this framework by way of regulations. Definition of standards. What are the standards actually? When we are talking about standards, we actually mean the standards denote the minimally acceptable and aspirational level of performance. In the context of radiation protection, good performance will actually be the amount of exposure that we give to the people who are concerned. Therefore, in radiation protection context, good performance being exposure amounts within the set limits for various exposure situations. The functional purpose of these constraints and set limits is to set boundaries. And therefore, the dividend, what we get out of these boundaries is to mitigate exposure risks, where in general population, the risk is found to be minimal when the exposure or the level of radiation is at normal background. But for purposes of patients, the risk is found to be minimal at typical medical exposures. Typical medical exposures are determined by the professionals in the medical or in the hospital services. So these guys should be able to determine what are the typical exposures for various procedures that they are dealing with. And for radiation workers, the risk is found to be minimal at exposures that are allowed by the statute. You'll find that in different countries, these exposures will vary, but they will vary slightly because the overall limit has been set by the International Atomic Energy Agency. Safety and protection standards as a value driver for the national radionuclear enterprise. This simply means in Botswana, we have this enterprise, so we have people, different stakeholders who are using radiation technologies for various ends. And we find that there is a value in using these technologies. There is also a value that is derived from applying the standards as they are given or administered by RPI. Therefore, radiation safety and protection standards are an essential cog in the radionuclear ecosystem. because they provide an environment for equity amongst all players. They also provide some measure of justice because we use the standards in order to judge everybody who is using the technologies, using the same standard. And they also provide some measure of sustainability. When you are applying the standards, there is a measure of sustainable use of your technology. They are a value driver. They are a value driver for practices that are technology driven, as well as those activities that are enabled by the technology. Technology here, we are referring to radiation or nuclear technologies. In Botswana, this is even more evident where we find that the disparate communities of technology users. These are communities of people who are not linked by any profession or any mission. These are people coming from different areas who are using the technology, whether they are private or public, whether they are professionals or non-professionals. They are able to use these technologies safely because they are guided by the standards, and they are able to engage in their businesses and derive a social as well as economic value. But you realize that this comes at a minimal cost to them. They do not have to incur a lot of cost in order to use these radiation technologies. As we continue, you realize that I'm just trying to demonstrate how the value of the standard or the radiation protection standards is found within the value chain of the whole enterprise. So, in terms of the standards, you find that the scientific, starting from the left side, the scientific discovery of the essence or the nature of radioactive elements. The scientific discovery of the essence and the nature of these radioactive elements is the one that has given rise to the standards of protection and safety. The essence here and nature simply means the properties of the elements which were found at the time. We shall realize that as we move on, we shall touch base on these properties that are being alluded to here. As the essence or properties were found, there was also, if you move to the right, there was incorporation of these elements or sources into various technologies to harness this radioactivity. So this radioactivity phenomenon was found to be useful for various purposes. Therefore, it was harnessed, or it is being harnessed in various technologies for various use. There is also deployment of technologies, different technologies for that matter, in various socio-economic activities across the landscape. This simply means that the technologies in Botswana that employ or that are driven by a nuclear or the technologies that are driven by this radioactivity phenomenon are used for different activities in Botswana. We shall discover that later on. And the ultimate value is such that for radionuclear enterprise, there is an improvement that is being found due to the deployment or use of the standards being elements that actually guide the use of these technologies. There is also found to be advancement of science and technology in the area of radiation, as well as the standard of life of humanity. So the application of standards give a sense of protection not only to the environment and the people as well as property, but within the processes that we employ. And you realize that this is where the value is derived as we move along the value chain. Application of radiation safety and protection standards. The standards of safety and protection as relates to radioactive sources, whether they are natural or artificial, are derived from the properties of elements in question. This is the properties or the essence or the nature of these elements that are found in nature, or these elements that may be manipulated and manufactured artificially, especially their ability to ionize air. This is one property that has been found to be associated with nuclear elements, whether they are natural or they are artificial. They ionize air. They are found to penetrate non-transparent matter, and are also found, or it is the phenomenon is found to interact with and alter the physiology of living matter. If you look at this, you realize that this is where the aspect of radiation protection comes in. It really comes in from the fact that this matter, which is found to be having this phenomenon, or which is exuding or showing this phenomenon of radioactivity, is able to ionize air. It is also able to penetrate non-transparent matter, and in the process, it is able to interact with and alter the physiology of living matter. Therefore, the primary protection standards, as I've indicated or alluded to, they are actually flowing or derived from the essence or the nature of the elements. These elements, whether they are found in nature, natural, nuclear elements, or they are artificial. Therefore, if we look on the right side of the arrow, we'll find that there are radiation protection standards that have been derived and then are applied as we use the technologies. Some of the standards are the standards of the IT technologies. These IT technologies are the brains behind levels of radiation that is being emitted by other technologies, either in hospitals or in construction, or it may be any other activity. So the IT technologies, they do have standards. These standards derived, or they are dependent on the primary element which is exuding this radioactive technology. We also have the standards that are derived for technologies of radiation emitting devices. We do have radiation emitting devices in the various form, used in hospitals, used in construction, used in manufacturing, used in mining and exploration, and many other areas. So these technologies really they have the standards because they do have sources in them. The sources actually would be the material, whether in a lot of cases this material would be artificial material. So there are standards that are used to construct these devices that are holding the sources. We also have the standards that are derived for physical facilities. If you look at the hospital, and especially at the radiation unit or radiation department, you realize that the material that is used to construct the radiation department or the walls of the radiation department are derived from looking at the radiation material that will be used. At the same time, we also have the levels of the windows. The windows are placed at a point which is unlike any other point, whether it be at the ward or any other place in the hospital. So all these are considerations, or these are construction standards which have been derived from the radioactive sources, or in consideration of the radiation sources that are being used. We also have the engineered controls standards. If you look at going back to radiation department again, there are engineering controls that are used within the radiation departments. There are devices, there are things that are used within the radiation department, and these controls actually have the standards that are, dependent on the standards of the essence, or the considered, to protect the people in the radiation department, considering the materials that have been used. There are also materials and equivalents. There are materials that are found not to be penetrated by this essence called radioactivity. Therefore, all the materials that are used and their equivalents, are deriving their values or standards from the standards of protection. If I were to give an example, some of the materials that are used to encase, or to protect against radiation would be depleted uranium, but we know how heavy that may be. Therefore, we look for equivalence of, if the uranium material is to be found to be of this, this weight, we could look for its equivalent, which is less weighty than the depleted uranium, and we use that equivalent in lieu of the depleted uranium or lead. So all these equivalents are used. There are the standards of constructing these equivalents in order to protect, people, the environment, and the properties that are found where these materials are, and the standards are derived from the essence of the materials. We also have the scientifically derived principles. When we are dealing with radiation, we know that scientifically it has since been proven that one has to have to spend less time in the radioactive field. You also have to have, to be a distant from the source. Therefore, there is a principle of time. There is also a principle of distance. You also have to be shielded if you are within the ionizing radiation field. So these are some of the principles that are being deployed or used in order to protect people from being exposed. At the same time as we are having these principles of time, distance, and shielding, we do have justification. Justification is another principle. Of course, it's a governance principle to say, you know, what we are bringing in the country that uses the technologies of radiation is justified to be used. There is a good reason why the technology has to be used in Botswana. That is a principle of justification. If it is not justified according to those who make decisions, they'll be guided by the principle of justification not to accept this technology to be used in Botswana. There is also the principle of optimization. This means that at the same time that we are using these radiation technologies, we have to keep on making sure that we optimize our processes in order to be within the limits, the standards that have been set. We also have to look at the processes, or we also have to be looking at the things that we use, the technology, whether we can change the technology to use the one that may be less likely dangerous than the ones we are using right now, so that we can optimize our protection and safety. So these are some of the principles, let me just say the cardinal principles that are being used, as well as the set limits and constraints All these in totality are used to protect the people. These are the standards that protect people, environment, and property. Moving right along, we realize that standards are actually meant to protect the populations, the property, and they are also meant to safeguard the environment. In conclusion, ladies and gentlemen, you will realize that application of standards is something that is of value to the whole nuclear enterprise in Botswana. So, development, deployment, and administration of radiation protection standards and their use by various stakeholders to manage performance and coupled with continuous optimization of safety and protection is a national public good. And this national public good has got positive global implications. So, with that, ladies and gentlemen, I think I've just given you a comprehensive but short overview of the application of standards of radiation protection and safety in Botswana and why they matter in our everyday life as we deploy and use the radiation emitting technologies. Thank you.